Okay, this is the continuation of exercise 10.1, question 9. Sorry, the video ended abruptly there. In this last part of the question, we had to answer this question: how many solutions does the equation x squared plus x plus 4 equals 0 have? Now, this is the equation and the graph of y equals x squared plus x plus 4. So if you want to solve this, x squared plus x plus 4, we're just replacing the y here with a 0. But we see that this x squared plus x plus 4 never has a value of 0. It would actually have to cut the x-axis here to have a value of 0. Therefore, how many solutions does that equation have? Well, the equation x squared plus x plus 4 equals 0 has no solutions. And the reason is because it does not cut, one sec, it is because it does not cut the x-axis. And remember, it is on the x-axis where y equals 0. Okay? We're just going to do another question from exercise 10.1. Okay, this is exercise 10.1, question 19. And the question is to sketch the parabola y equals 3x squared minus 2x plus 4, and hence show that 3x squared minus 2x plus 4 is greater than 0 for all x. First thing, we need to sketch y equals 3x squared minus 2x plus 4. Notice that the coefficient of the x squared term is positive, so therefore this parabola is concave up. Also, we can find the y-intercept by substituting x equals 0, and if we put x equals 0 there and there, we get that the y-intercept is 4. So we're painting a little bit of a picture here. We know that the parabola is concave up, okay, it's upwards, and the y-intercept is 4. You are not able to draw it at the moment because you don't know where the axis of symmetry is. So the axis of symmetry is found by using the formula x equals negative b on 2a, which is negative 2 over 2 times 3. Which is 2 on 6, which is a third. So the axis of symmetry is the line x equals a third, which I've drawn in here. So this is the axis of symmetry, x is a third. So you know that it's got a y-intercept. Okay, sorry for the interruption again. We're just substituting x equals a third into this equation here. When we substitute it, we get 3 times a third squared minus 2 times a third plus 4. And we end up with a third, 3 times 1/9, which is a third, minus 2 times a third is 2/3 plus 4. And if you work that out, you will get 3 2/3. So therefore, the vertex of this parabola is 1/3, that's the x value, and the y value is 3 2/3. So therefore, the minimum value of the parabola is 3 2/3. And so the parabola, because it's concave up and the y-intercept's 4, and the vertex is here at a third, 3 2/3, the parabola would have to look like that. Now we can see that this parabola is always greater than 0. See, y equals 0 is the x-axis. So always every value of y, no matter, which values of x that you substitute along here, you will always get a positive value for y. So therefore, y will be greater than 0 always, or this parabola, because the parabola is y equals 3x squared minus 2x plus 4, then these values of this parabola are always greater than 0. So therefore, this parabola is always greater than 0 because the graph is always above the x-axis and always has positive y values. The other thing here is if we try to factorize this, y equals 3x squared minus 2x plus 4, we would find that we can't do it, okay? Now we're looking at this in more detail in exercise 10.3, so I'm just going to leave that there. Now the questions for exercise 10.1 were given out in class today, and I'll email them to those that weren't there today. Now we're going to start with exercise 10.2, quadratic inequalities. Okay, you might want to copy the notes down first. So quadratic inequalities, that's just a quadratic equation with a greater than 0 or less than 0 or greater than or equal to 0, for example. Okay, now for any curve on the number plane, y equals 0 indicates the x-axis, so I'm just going to draw a quick sketch here. So anywhere along the x-axis is where y equals 0, because all values of y are 0 on the x-axis. Y greater than 0 is is always above the x-axis because the positive values of y, if we look at the values of y up here, they're all positive. So y greater than 0 is up here. Y equals 0 is on the x-axis. And y less than 0 is below the x-axis because all the negative values, if I look at these values of y and what they are down here, they would be -1, -2, etc. So the negative values of y are always below the x-axis. Now, of course, this applies for any graph that we might draw, including the general parabola, y equals ax squared plus bx plus c. So, for the parabola, y equals ax squared plus bx plus c, if we want to see where that parabola equals 0, it would be on the x-axis. Now I've got a concave up parabola here, and I've got a concave down parabola here, where a is less than 0. So therefore, anywhere on the x-axis, and if we look at these two parabolas, we've got 2 points there and 2 points here. So anywhere on the x-axis is where the parabola equals 0. Okay? Now, for the concave up parabola, these values up here, these particular x values that relate to here, is where the curve is above the x-axis. So this is where the parabola is positive, okay, where the y values will be positive, okay? And for this concave down parabola, this is where the parabola will be greater than 0, or it will have positive y values up here. And for this concave, so these were all greater than 0 values up there, okay, and here as well, greater than 0 values there, okay. And then we've got below the x-axis is where we have less than 0 values. So anywhere down here is where the parabola is less than 0. So this is where ax squared plus bx plus c is less than 0. And on this concave down parabola, it's anything below the x-axis as well. So this in purple or whatever is where this parabola is less than 0. And then exactly on the x-axis is where, I can do that in green or something, exactly on the x-axis is where the parabola is equal to 0. Okay, so we've got the black area greater than 0 is above the x-axis, equals 0 here is on the x-axis, so it's these points on the x-axis, and less than 0 are these bits below the x-axis. Now, you've already solved some of these earlier in the year, but this is revision. So solve x squared minus 9 is greater than 0. First, you need to sketch the parabola y equals x squared minus 9. Now, if we look at that quickly, we know that the parabola is concave up because the coefficient of the x squared is 1, which happens to be greater than 0. We also know that the y-intercept is -9 because to find the y-intercept, we substitute x is 0 and we get -9. So now we know that we've got a concave up parabola with a y-intercept of -9. Now, to find x-intercepts, so whenever you're asked to solve something like this, you're going to have to find the x-intercepts and then look for the part of the graph that's above the x-axis. So for x-intercepts, we put y equals 0. So we put y equals 0 here, and we get 0 equals x squared minus 9. Now, to solve this inequality, x squared minus 9 is greater than 0, you have to first solve x squared minus 9 equals 0, which is what we're doing here. We can factorize x squared minus 9 because it's a difference of two squares. So we get x minus 3, x plus 3, because this is really x squared minus 3 squared. And solving this, so if x minus 3 times x plus 3 is 0, then we know that x is either equal to 3 or -3. So my solutions here are 3 and -3. So I know that my curve passes through y-intercept -9, and that the x-intercepts are 3 and -3, and that it's concave up, so then we can draw the parabola. So where is this parabola greater than 0? Well, it's greater than 0 above the x-axis. So therefore, the solution, where is this parabola above the x-axis? We need to give x values here in our solution. So the solution will be for x values less than -3 and for x values greater than 3. Now, exercise 10.2, question 10. Solve 6 minus x minus x squared is less than or equal to 0. Okay, now to solve this, we need to put this equal to 0 and solve first, and then we'll see where is the curve on or below the x-axis. But first we need to sketch y equals 6 minus x squared. Now, just looking at this, we need to look at the coefficient of the x squared term, and it's -1. So the curve is concave down. Okay, so as I was saying, to work out the x-intercepts, you put y equals 0 here, so we get 0 equals 6 minus x squared, and that's written down here. Now, it is a little bit difficult to factorize something with a negative x squared, so we're going to take everything over to the other side. Now, we only do this for the purpose of factorizing and solving. It does not now mean that the parabola is concave up. So we're only taking this over, all of this over to the other side to help solve this equation. So please don't go and draw a concave up parabola here, because it's actually a concave down parabola that we're drawing. So bringing them all over to the other side, we get x squared plus x minus 6 equals 0. Factorizing that, factors of -6 that add up to +1 would be +3 and -2. So just checking, x squared minus 2x plus 3x minus 6 equals 0. Solving this, we get x is -3 and 2. So x is -3 and 2 are my x-intercepts. The axis of symmetry, I mean, you can use the formula x is -b on 2a, or knowing that the axis of symmetry is halfway between the x-intercepts, so it would be the average of the x-intercepts. So you go -3 plus 2 divided by 2, making my axis of symmetry having equation x equals -1/2. So that's my axis of symmetry there, x is -1/2. So I really don't need to know what the maximum value here is, but it will be bigger than 6, that's all we know. Now we need to see where is this equation less than or equal to 0, so it can actually also be on the line or less than 0. So just shading that in here. So therefore this curve is less than or equal to 0 for values of x less than or equal to -3 and x greater than or equal to 2. So please make sure that you include the less than or equal to -3 and x is greater than or equal to 2, because it's here in the question. You're trying to solve where 6 minus x squared is less than or equal to 0. Now for exercise 10.2, question 17, to solve x squared minus 2x is less than 15. Now what we need to do is take everything over to the left-hand side, so that we've got a less than 0 here. So taking this 15 over to the other side, we get x squared minus 2x minus 15 is less than 0. Again, to be able to do this, we need to sketch the parabola y equals x squared minus 2x minus 15, and then we need to see where that parabola is less than 0. So we sketch that. To sketch that, let's just look at a few important points. We know firstly that the curve is concave up, because the coefficient of the x squared is 1, which is positive. The y-intercept is found by substituting x is 0, and that y-intercept is -15. And for the x-intercepts, we substitute y equals 0. So we put 0 in here, and we get 0 equals x squared minus 2x minus 15. That's down here. We can factorize that to get x minus 5, x plus 3. I'm just checking that, and it looks fine. Solving that equal to 0, we get that x is 5 or x is -3, so we can quickly sketch that. Now, having a look at where the axis of symmetry would be, it would be halfway between the values of 5 and -3. So adding them together, you get 2 divided by 2, which is 1. So the axis of symmetry is x equals 1. That's your axis of symmetry. So the vertex here will be 1 something. Now, I'm not going to work out what it is, but we do know that the y-intercept is -15. So if I do substitute x is 1 actually into this equation, I can see I get 1 minus 2, which is -1 minus 15. Actually, I get -16, which does make sense because it has to be lower than -15. So the question is to solve that. Now, because we took the 15 over to the other side, we're actually really solving this. This is our question now. So where is this less than 0? Where is this parabola less than 0? And it's less than 0 for all of these values in here, for all of these x values. So the solution will be that x lies between -3 and +5. We do not put less than or equal to because it's not less than or equal to there, it's just less than. Okay, now for question 13 from exercise 10.2. Okay, in this question we're asked to solve 35 plus 9k minus 2k squared is greater than or equal to 0. First we need to sketch the parabola y equals 35 plus 9k minus 2k squared. First thing we can look at is that the curve. Okay, so again y-intercept is 35. Now to find the x-intercepts, or in this case the k-intercepts, sorry because this is a k, I'll just fix that up. So to find the k-intercept, so this is actually y versus k, not y versus x. So to find the k-intercepts, we put y equals 0. So we put 0 equals 35 plus 9k minus 2k squared. Now just for the sake of factorising it, we can take everything over to the left, but that will make it positive 2k squared minus 9k minus 35 equals 0. Just remembering again that the parabola is still concave down, it's not concave up because this is what we are sketching. Okay, factorising that we get 2k and k are factors of 2k squared, and factors of 35 are 7, negative 7 and 5. So we get 2k plus 5k minus 7, and just expanding that, yes, that works. And therefore solving that we get 2k plus 5 is 0, or k minus 7 is 0, which means that k is negative 5 on 2, which is negative 2.5, or k is 7. Just sketching that quickly, we know that the curve is concave down and that the y-intercept is 35. The axis of symmetry will be somewhere over here, it'll be halfway between 7 and negative 2.5. You can average 7 and negative 2.5. Or you can use the formula for the axis of symmetry, which is x equals negative b on 2a, and you get negative 9 over negative 4, which is positive 2.25. So this is the axis of symmetry. X is 2 1/4. Now the question says to solve this, but to solve 35 plus 9k minus 2k squared. So where is this parabola greater than or equal to 0? So it will be greater than or equal to 0 on the line. It's equal to 0 on the line, and it's greater than 0 above the line. So the solution for this will be, so the solution is between negative 5 on 2 is less than or equal to x, which is less than or equal to 7. Okay, so it includes both the negative 2.5 and the 7 because we've got a greater than or equal to here. So we're looking at where is. Okay, now the following is revision of work that we completed in term 1. So it's still exercise 10.2. It's extension 1 content only, and it is revision of work covered in extension 1 in term 1. And the first question here, we're actually solving inequalities with pronumerals in the denominator. Now because this denominator can be either positive or negative depending on the values of x that your solution will be, you cannot just go multiplying the other side here by x plus 3 because we're not sure whether we need to flip the inequality sign or not. So the way that we solve something like this, solve 3 over x plus 3 is greater than negative 1, is that we multiply both sides by whatever the denominator is squared. The reason we multiply it by x plus 3 squared is that we know that x plus 3 squared will always be positive, and so therefore the inequality sign will remain unchanged. So we've got 3 over x plus 3 times x plus 3 squared is greater than negative 1 times x plus 3 squared. Now you'll notice the reason that we do this is that one of these x plus 3's on the bottom, on the denominator here, cancel with one of the x plus 3's on the numerator. And so we get 3 bracket x plus 3 is greater than negative 1 bracket x plus 3 squared. Now the thing here is I do not want you to expand here. I want you to just take this right hand side over to the left hand side, and we get 3 bracket x plus 3. I've actually got a 1 here. Plus 1 bracket x plus 3 squared is greater than 0 because we're taking everything over to the left. Now we can see here we've got. Okay, sorry, as I was saying, we take this over to the other side. Because x plus 3 is a factor in both of these terms, we remove the x plus 3. And in the first term, we've got a 3 left over, plus in the second term, we've got 1. Now, I don't need the 1 there. And we've got 1 of the x plus 3's remaining bracket, greater than 0. So we've got x plus 3 bracket, and then we expand this bit here, and we get 3 plus x plus 3, which is x plus 6, is greater than 0. Now, this... Okay, back here again, it's concave up, x-intercepts are -6 and -3, so sketching that parabola, as I was saying, if you wanted, you could put the y-intercept, which is 18, which would be up here somewhere, but there's no need to do that. It's not required for our solution. So to be able to solve this whole thing, we've come down to this line here, where x plus 3 bracket x plus 6 has to be greater than 0. So where is this parabola here greater than 0? Well, it's greater than 0 for all of these values above the above the x-axis. So therefore the solution to this inequality will be, so my solution is x is less than -6 and x is greater than -3. Now notice it's just a greater than sign, not a greater than or equal to, so this is my solution. X is less than -6 and x is greater than -3. I'll just fix this up again. I've actually deleted just about everything off my computer, so I don't know why it's still doing it, but I'll be back. Okay, now for the last question in exercise 10.2, question 30, solve x over x plus 2 is greater than or equal to 4. Again, we've done this earlier in the year. This is just a revision. We have a pronumeral in the denominator. Now the way to get rid of that is to multiply both sides by x plus 2 squared. Now if we multiply both sides by x plus 2 squared, one of the x plus 2's up here cancel with this one down here, and we're left with x bracket x plus 2 is greater than or equal to 4 bracket x plus 2 squared. If we then take this bit on the right hand side over to the left hand side, we get x bracket x plus 2 minus 4 bracket x plus 2 squared is greater than or equal to 0. Now I do not want you to factorize, I do not want you to expand this. I would like you to factorize it. So x plus 2 here is a common factor. We pull that out, and what are we left with? I'll just underline what we take out. So we take out the x plus 2. And we're left with x minus 4 and one lot of the x plus 2 here, because one lot of the x plus 2 went out there. Brackets is greater than or equal to 0. So the x plus 2 here stays the same. We expand this bit and we get x minus 4x minus 8. And this bit stays the same. The x plus 2 stays the same, and we get minus 3x minus 8. So we've got x plus 2 and minus 3x minus 8 is greater than or equal to 0. Now this here is a parabola. So we have to sketch y equals x plus 2 bracket x minus, negative 3x plus 8 bracket. Now this, if you multiply the x terms only, we know that you get negative 3x squared, so therefore it's concave down. So this will be y equals negative 3x squared, etc. Okay? So it's concave down. Also, if we look at the y-intercept by just multiplying the constant terms, we will get minus 16. I haven't written down what the middle term is, but I may as well now. So I've got minus 3x squared minus 8x minus 6x will give me minus 14x minus 16. So we can see concave down and that the y-intercept is negative 16. Okay? Now remembering that, yes, we are trying to solve the original equation up here, but it's now been transformed into solving this equation here. So I just need to now refer. Okay, now just continuing this question. Remember, we're trying to sketch this. So first we'll sketch that, and we worked out that this is a concave down parabola because the coefficient of the x squared is negative, and that the constant term here was negative 16. So if we put this equal to 0 to find our x-intercepts, we get that x is negative 2 and we get that x is 8 on negative 3. 8 on negative 3 happens to be negative 2 2/3. So here we'll just sketch our x-intercepts. They're negative 2 and negative 2 2/3. We know it's a concave down parabola, so it's like that. We need to see where this parabola is greater than or equal to 0. So it's greater than or equal to 0 for these values, including these two. Now if we look back at the original question, we noted that the denominator here is x plus 2, and so x cannot equal negative 2. So here, looking at my solution, we say my solution lies between negative 8 on 3 is less than or equal to x, but it's less than 2 because x, notice that x cannot equal negative 2. We said that up earlier. So we can't put a less than or equal to sign here. It's negative 8 on 3, which is negative 2 2/3, is less than or equal to x, which is less than 2. So that's my solution. So now, if you could please just do exercise 10.2, question 5, 11, 15, 18, 20, 24, and 27 from exercise 10.2. Thank you. Sorry, and just quickly going back to here, this is a negative 2 here because